In 1981, electrical codes mandated that wall receptacles were required to be grounded. This requirement was part of the ongoing evolution of electrical safety standards aimed at protecting individuals from electrical shock hazards. Grounding, or bonding, provides a low-impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices such as circuit breakers or fuses. This is important because if a fault occurs, such as a live wire coming into contact with a metal enclosure, the fault current will flow through the grounding path, causing the circuit breaker to trip and de-energize the circuit. Without proper grounding, the metal enclosure could become energized, posing a significant shock hazard to anyone who touches it. The implementation of grounding requirements in the electrical code reflects a growing awareness and understanding of electrical safety principles. Prior to widespread grounding requirements, electrical systems were more susceptible to creating hazardous conditions. Ungrounded systems could allow fault voltages to build up on conductive surfaces, creating a dangerous situation. Grounding helps to stabilize the voltage with respect to ground, preventing these voltage buildups. The National Electrical Code, or NEC, plays a crucial role in establishing and updating these safety standards. The NEC is a set of guidelines and regulations for electrical installations that is developed and maintained by the National Fire Protection Association, or NFPA. It is widely adopted by states and local jurisdictions in the United States, and it provides a comprehensive framework for ensuring electrical safety. Changes and updates to the NEC are made periodically to reflect advancements in technology, new safety concerns, and lessons learned from past incidents. These updates can include revisions to grounding requirements, wiring methods, overcurrent protection, and other aspects of electrical installations. When working with electrical systems, it is essential to consult the relevant edition of the NEC and to follow all applicable codes and regulations. This helps to ensure that the installation is safer and compliant with industry standards. Electrical work should only be performed by qualified and licensed electricians who have the necessary knowledge and experience to do the job safely and correctly. Incorrectly installed or improperly maintained electrical systems can pose serious hazards, including electrical shock, fire, and equipment damage. Therefore, it is important to prioritize safety and to follow all applicable guidelines and regulations. Grounding wall receptacles is a fundamental aspect of electrical safety. It helps to protect people from electrical shock by providing a low-impedance path for fault current to flow. This allows overcurrent protective devices to quickly de-energize the circuit in the event of a fault, minimizing the risk of injury or damage. The NEC specifies detailed requirements for grounding electrical systems, including the types of grounding conductors that are permitted, the methods for connecting grounding conductors, and the requirements for grounding electrodes. These requirements are designed to ensure that the grounding system is effective in providing a safe and reliable path for fault current. In addition to grounding, bonding is another important aspect of electrical safety. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. The NEC also specifies detailed requirements for bonding electrical systems, including the types of bonding conductors that are permitted, the methods for connecting bonding conductors, and the requirements for bonding different types of equipment. Grounding and bonding are complementary safety measures that work together to protect people from electrical shock and to prevent damage to equipment. By providing a low-impedance path for fault current and by ensuring that all metal parts are at the same electrical potential, grounding and bonding help to create a safer electrical environment. When installing or maintaining electrical systems, it is important to pay close attention to grounding and bonding requirements and to follow all applicable codes and regulations. This will help to ensure that the electrical system is safe and reliable. In residential wiring, grounding typically involves connecting the grounding conductor from the receptacle to the grounding busbar in the electrical panel. The grounding busbar is then connected to a grounding electrode, such as a ground rod or a metal water pipe, which provides a connection to earth. This connection to earth provides a lower impedance path for fault current to flow, allowing the circuit breaker to trip and to energize the circuit in the event of a fault. In commercial and industrial wiring, grounding requirements may be more complex, depending on the size and type of electrical system. Grounding systems in these applications may involve multiple grounding electrodes, grounding conductors of different sizes, and specialized grounding techniques. The NEC provides detailed guidance on grounding requirements for various types of electrical systems and applications. When working with electrical systems, it is important to understand the different types of grounding and bonding conductors that are available. Grounding conductors are typically made of copper or aluminum and are available in a variety of sizes. The size of the grounding conductor must be adequate to carry the expected fault current without overheating. Bonding conductors are also typically made of copper or aluminum and are available in a variety of sizes. The size of the bonding conductor must be adequate to provide a low impedance path for fault current. In addition to grounding and bonding conductors, there are also various types of grounding and bonding connectors available. These connectors are used to connect grounding and bonding conductors to equipment, enclosures, and other metal parts of the electrical system. It is important to use connectors that are specifically designed for grounding and bonding applications and that are listed and labeled by a recognized testing laboratory. When installing grounding and bonding conductors and connectors, it is important to follow all applicable codes and regulations and to use proper installation techniques. This will help to ensure that the grounding and bonding system is effective in providing a safe and reliable path for fault current. Improperly installed or maintained grounding and bonding systems can pose serious hazards, including electrical shock, fire, and equipment damage. Therefore, it is important to prioritize safety and to follow all applicable guidelines and regulations. The evolution of grounding requirements in the electrical code reflects a growing understanding of electrical safety principles and a commitment to protecting people from electrical shock hazards. By requiring wall receptacles to be grounded, the electrical code helps to create a safer electrical environment for homes, businesses, and other buildings. Grounding and bonding are essential components of any electrical system. They provide a low impedance path for fault current, which helps to protect people from electrical shock and to prevent damage to equipment. When installing or maintaining electrical systems, it is important to pay close attention to grounding and bonding requirements and to follow all applicable codes and regulations. This will help to ensure that the electrical system is safe and reliable. The NEC provides detailed guidance on grounding and bonding requirements for various types of electrical systems and applications. It is important to consult the relevant edition of the NEC and to follow all applicable codes and regulations when working with electrical systems. Electrical work should only be performed by qualified and licensed electricians who have the necessary knowledge and experience to do the job safely and correctly. Incorrectly installed or improperly maintained electrical systems can pose serious hazards, including electrical shock, fire, and equipment damage. Therefore, it is important to prioritize safety and to follow all applicable guidelines and regulations. Grounding wall receptacles is a fundamental aspect of electrical safety, and it is an important requirement of the electrical code. By grounding wall receptacles, we can help to protect people from electrical shock and to create a safer electrical environment for everyone. Furthermore, the grounding of electrical systems ties into the broader context of power distribution and safety measures within buildings and infrastructure. A properly grounded system not only protects against immediate shock hazards but also contributes to the overall stability and reliability of the electrical network. This includes minimizing the risk of voltage fluctuations and surges, which can damage sensitive electronic equipment. The grounding system works in conjunction with other protective devices such as surge protectors and uninterruptible power supplies, or UPS, to provide comprehensive protection against electrical disturbances. These devices help to mitigate the effects of lightning strikes, power grid fluctuations, and other transient events that can disrupt the flow of electricity and cause damage to equipment. In addition to its role in safety and equipment protection, grounding also plays a critical role in electromagnetic compatibility, or EMC. A well-designed grounding system can help to minimize electromagnetic interference, or EMI, which can disrupt the operation of electronic devices and systems. This is particularly important in environments where sensitive electronic equipment is used, such as hospitals, laboratories, and data centers. The grounding system provides a low impedance path for unwanted electromagnetic signals, which helps to prevent them from interfering with the operation of other devices. The NEC addresses EMC considerations in its grounding and bonding requirements, and it provides guidance on how to design and install grounding systems that minimize EMI. The NEC also covers the requirements for grounding different types of equipment, including electronic equipment, motors, and generators. Each type of equipment has its own specific grounding requirements, depending on its design and application. For example, electronic equipment typically requires a dedicated grounding conductor to minimize noise and interference, while motors and generators may require larger grounding conductors to handle the higher fault currents that can occur in these devices. The NEC also addresses the grounding of specific types of wiring systems, such as metal conduit, cable trays, and flexible metal conduit. These wiring systems must be properly grounded to provide a continuous electrical path for fault current and to prevent the buildup of static electricity. The NEC provides detailed guidance on how to ground these wiring systems, including the types of grounding conductors and connectors that are permitted. In addition to the NEC, there are also other standards and regulations that address grounding requirements, such as those promulgated by the Institute of Electrical and Electronics Engineers, or IEE, and the Occupational Safety and Health Administration, or OSHA. These standards and regulations provide additional guidance on grounding design, installation, and maintenance, and they may be applicable in certain situations. It is important to be familiar with all applicable standards and regulations when working with electrical systems. In summary, the grounding of wall receptacles in 1981 was a significant step forward in electrical safety. It reflects a growing understanding of the importance of grounding in protecting people from electrical shock and in preventing damage to equipment. The NEC provides detailed guidance on grounding requirements for various types of electrical systems and applications, and it is important to follow all applicable codes and regulations when working with electrical systems. Electrical work should only be performed by qualified and licensed electricians who have the necessary knowledge and experience to do the job safely and correctly. By prioritizing safety and following all applicable guidelines and regulations, we can help to create a safer electrical environment for everyone.